I have 12:30 by the clock on the computer, so we will get started. And so that you know, I am recording today's session, and you'll understand why in just a minute, but I'm recording it so that I can post it and you'll have access to it should you need it. I want to begin with an announcement. We are not going to physically meet here in the classroom on Wednesday, September the 14th, which is 2 days from now. My husband is having a major back surgery tomorrow at Erlanger Hospital in Chattanooga, and it's going to be there several days, but I've gotten permission to cancel class on Wednesday because of that. But you do have an assignment to do. We're going to backtrack to class participation number 4, and then you're going to be ready by the end of today to do class participation 5. So the expectation is that in lieu of class, you're going to be working on those 2 assignments, and they're due by Friday, which is the 16th of September. So I want to start out with backtracking just a little bit to qualitative data and show you what the expectation is for class participation 4. So in the course, in D2L, remember there's a folder under the content on the right-hand side called Classroom Participation Activities. And you are ready to do class participation 4. And it is related to qualitative data, which was actually the discussion at the end of module 1, where you had to create a categorical frequency distribution. We're going to be using the data that we collected from the class survey. Now you may say, well, Ms. Ralston, where's the data? Well, there will be an announcement that will post into the course at midnight that has the data set, but also the data set is already posted under the announcements. It says data set for class participation activities. Okay, and we'll talk about that again in just a minute. Okay, but let me go back to that class participation activity. Gonna make me reopen it. Okay, so it's divided. You don't do 5 of them, you're only doing 1. And the one that you do is based upon the first letter of your last name. So for example, I know that Chris's last name is Buchanan, which starts with the letter B. So Chris is expected to create a categorical frequency distribution for eye color. Okay. Donnie's last name is Irvin, and so start with the letter I. So he's going to be expected to do a categorical frequency distribution for the pathway. Okay, based on the first letter of your last name. You only do 1. You will have to list out the categories. Remember, those should be in alphabetical order unless it's something where it has a natural order. For example, birth months, you would likely list out January, February, March, April, and so forth. Okay, the others should be alphabetical. You'll determine the frequency, which is a number, not tick marks, and then calculate the relative frequency. And I request that you put it in percentage form. Okay, now the second thing that you have to do is you're going to use Minitab to create a bar graph. And then there's 2 questions that you have to answer about the data set. Okay, so it's really 4 questions. It shouldn't take you a lot of time to do. I do want to show you how to get the data set into Minitab. Okay, I've shown you before, but I figure you've forgotten. Okay, so I'm going to app.minitab.com You can access Minitab from any computer on the campus, should you be on the campus. You also, I told you, you could get it downloaded to your personal device, and the instructions for that are in D2L under the Start Here folder, and there's a folder labeled Minitab Online. And it's thinking about it really hard. Why won't you send me a push? Okay, let's try again. Yeah, I typed something. Okay, so I have Minitab open, and I want to bring the data set that I have provided to you into Minitab. Okay, again, at the moment, it's in the announcements under the header data set for class participation activities. It's attached to it. It is in an Excel format. So I'm going to click on it and have my computer open it. So I'm going to click, it downloads it, and then I open it. Okay. Then I want to copy all of the data set, not just one column, not just two columns. I'm going to copy the entire data set. To copy the entire data set, I'm going to put the mouse in the corner in the upper left where the rows and the columns meet. And I click. And my spreadsheet kind of turns gray with a green border. And then I'm going to select the option at the top of the screen which says copy. And you'll notice little, I call them dancing ants, little dotted lines going all the way around the spreadsheet. So I know that it's copied. Then I'm going back to Minitab. And I put my mouse in the gray area under C1. It's easier at this point if I right click and tell it to paste. I want it to paste all of the cells. I'm continuing without autosave because I'm here in the classroom. And it will automatically put every column and every row of my spreadsheet in there. And the rows, or excuse me, the columns are labeled. Sam mentioned a while ago, Chris was going to do eye color. So he's going to use column 2. Donnie's going to use pathway. He's going to use C3. I don't know if I mentioned it before, but remember we talked about the little T, C2-T. T stands for text, T-E-X-T. Minitab recognizes that those columns are words, and it's not going to let you do things that you can't do with words. Like it's not going to let you try to add that column together because they're words, not numbers. Okay, so you get your data in there. Okay. Then you're going to create your graph. I'm not going to use this data set because I don't want to do anybody's assignment for them. So I'm going to put in a new spreadsheet. Let's see. I want a new worksheet. Okay. If you have the data that you have to type in yourself, like for example, if I just did eye color for this class, now the data set that's in there has more than just this class. Okay. Your options are blue, green, brown, or hazel. Blue, green, brown, or hazel. Tell me your eye color. Green. Oops. Make sure you spell it right. Luis, what color are your eyes? Blue, green, brown, or hazel? Chris.
Blue. Brown. Blue.
Sasha.
Green. Brown.
Okay, so there are 20 of you present. We included mine, they would be green, but I'm not going to include mine, okay? So if you have to enter your raw data, we talked about that before, you just type it in. But remember, the data always goes in a column. Now, let me walk you through the clicks in Minitab, should you wish to refer back to this when you're doing your project, on how to create your bar graph. Okay, so we have the data entered into the spreadsheet. I want to create a graph. Okay, Minitab is often very common sense. So I want a graph. So I go to the top menu bar to graph. And then I'm going to scroll the list until I find bar chart. Then I'm going to select it. I want counts of unique values because I entered each individual value. So I want counts of unique values. We only do one variable at a time. I have to select the variable. Now, this is where you would have to be careful because on your spreadsheet, you're going to have multiple columns. Make sure, you know, that you choose eye color or pathway or whatever your column is. I only have one in this spreadsheet, so it's eye color. And I click OK. And in the top half of the screen, I get my bar chart. The eye colors are across the bottom listed alphabetically. My frequency or count is on the vertical. Now, Minitab defaults and says this is a chart of eye color. But guys, we've talked about it over and over and over that it's important to have details. So I want to change this title. Okay, so I'm going to bring my mouse over to the graph and I'm going to click. And it outlines it in black. So I know that the graph is selected. Once it's selected, you should see in the upper right corner a black triangle that's turned upside down. It's like a drop-down menu option. If I click on it, it gives me some options. I want to go to Graph Options. And that opens up a window, and it's going to allow me to change the title. So I'm going to put eye color of GHC students. And it's fall 2022. Remember, you want to put details. You want to think about who, where, what, when. So we collected eye color of students at GHC in fall 2022. Now, when I hit enter, after I finish typing, it automatically changes it. The details are important. It gives your research context. The other thing that particular triangle will do when you select your graph, that drop down arrow gives you the option to copy the graph. You need to know how to copy because you need to put it into your document. So we choose the option to copy, and then I can go to my Word document, or if I needed to go to an Excel spreadsheet or PowerPoint, and I can paste it. So I'm in my document, I choose paste, and it automatically puts it there. It operates, Minitab operates very similar to Microsoft Word, Microsoft Excel, as far as copy and paste. Okay, that's class participation 4. Again, we're backtracking. Okay, but you should be prepared to do it. Later today, I'm going to show you how to do a histogram. We're going to get back on track with where we were at the end of class last week. Okay, so do you have questions before we move on? We'll talk a little bit more about classroom participation 5 as we get there. Okay, so last Wednesday, when we met, we talked about, we posed a question, and our question was, what is the average age in years of a GHC student in fall 2022? Remember, that's the first step in the research process, is to state your question clearly and with as much detail as possible, so that you can do step 2, which is to identify the variable, the population, the parameter, the sample, the statistic. Okay, and when doing that, we also identified the type of data we have, which we were doing age, which we decided was quantitative, discrete, because I asked for it in years and it's at the ratio level. Okay, so that was, we posed our question, we identified all of the necessary information. The third step then was to collect the data. So we went around and each of you told me your age, okay, for the 24 students that were present last Wednesday. Now, I know some of you weren't present, so you're not included in this data set. And we talked about how that data, even though it's a small data set, we call that the raw data. It was just a random list. And we talked about how that just with that random list, we're not really able to answer the research question, which is the ultimate goal. Okay, but we weren't able to do that. The next step in the statistical process is to take that raw data and begin to organize it so that we can then analyze it and ultimately answer our question. And so we looked at 3, really ultimately it'll be 4 different organizational tools. The first one was a grouped frequency distribution, which is a fancy way to say we made a table. One of the primary differences with the table or the grouped frequency distribution is that we use a range or a group of values rather than individuals. With the categorical and the qualitative data, we just listed the words out: blue, brown, green, or whatever topic you have. Okay, and they were individual groups. But with a data set with numbers, we tend to use a grouped frequency distribution. So we created a grouped frequency distribution. The first column in the frequency distribution is the groups. And I told you that on the test, I would give you those groups. Otherwise, all 24 plus of you could set it up differently and I'd be grading tables forever. Okay, so those are given to you. I will also tell you that if you look at class participation number 5, okay, again, you do only one and it's based on the last letter of your, or excuse me, the first letter of your last name, then that's the group you'll choose. But I give you the groups. So if your last name starts with an S to a Z, you're going to do number of siblings. And I tell you, use the groups 0 to 2, 3 to 5, and 6 to 8. So you would have to list those under the column for category. For credit hours, I tell you to use 3 to 5, 6 to 8, 9 to 11, and so forth. So I give you the groups. Now, granted, you're going to have to take what I tell you and write it in the column. But I think you can handle that. So even on that assignment, I've given you the groups, so you don't have to come up with them. The second column is the optional column, which is a tally, where you take your raw data, and each time it occurs, you put a tick mark. We then convert those tallies, tick marks, to a number. That's called our frequency. We talked about how that the sample size should equal the total frequency. And then we converted our frequency to a relative frequency to a percentage. That, remember, allows us to compare different sized groups. To get to the relative frequency as a percentage, it is the frequency divided by the total number in the group times 100%. And guys, to be a percentage, when you write it, you have to add that percent symbol. If you don't put the percent symbol, it is not a percentage. It's just a good old everyday number. You got to have the symbol. Okay, remember that your relative frequency should total to 100%, or at least be close. We do round typically to 1 decimal place, and so we could be a little bit off. Okay, so we did that. That's one organizational tool. And we said we learned some things from our grouped frequency distribution, but it didn't really help us answer the question, or we didn't get the answer to the question. We said we found that there were 9 students in the sample that were aged 15 to 19, 11 students aged 20 to 24, 3 students 25 to 29, and so forth. We said approximately 96% of the GHC students in the sample are younger than 30. Based on that organizational tool and kind of where the numbers fell, we estimated, without doing any calculations, that the average age of a GHC student in fall 2022 is about 20 years old. But again, that's just an estimate, and we've done no calculations. But that's kind of what we learned from our grouped frequency distribution. We then began to look at the organizational tools of graphs. We looked at the stem and leaf plot, which I mentioned to you, to me looks more like a table than it does a graph. It is best for a small data set. You wouldn't necessarily want to do a stem and leaf if you had hundreds or thousands of data values. We had 24, and I believe for the data set that you're doing for the classes, there's like 40, I think, 40, 42, something like that. Okay, so the stem and leaf is nice because it allows us to retain and order the raw data so we can see what's the lowest and what's the highest. We basically divided our data values by place value. The leftmost digit becomes the stem, which are listed vertically in the left column. The leaf is the rightmost digit. They are listed horizontally, low to high, and you have to include any repeats. And this was a little bit more helpful because we could begin to see that the youngest age was 16. The highest age on that particular day was 49. The most common age, which occurred 5 times, was 19. The value in the middle was 20. And we felt like our estimate of 20 was still reasonable based on this information, but yet we still had not answered the question. We're still just estimating and analyzing. Then we moved on to the histogram, and the histogram is like a bar graph, that is based on the grouped frequency distribution. And I rough sketched it right towards the end of class. And I mentioned to you that Minitab typically uses the midpoints for each group on the horizontal scale. The frequency is still on the vertical. Okay, and so this was my hand-drawn grouped frequency distribution, my hand-drawn histogram. I want to review with you because I don't think we got to do it, or we did it in a hurry at the end of class. I want to review before we go too much further how to do a histogram in Minitab. Okay, because you're going to need to know that for class participation 5, and then we're going to move on to some new information. Okay, so the first thing I'm going to have to do in Minitab is to enter the data. So I'm going back over to Minitab. I can use the same spreadsheet that I used before. I'm going to use column 2, and I'm going to put in ages in years of GHC students in fall 22. Again, I added some details into my title, which again can be helpful later on if I'm coming back to this data set. And then I'm going to enter the data that we collected the other day: 19, 19, 18, 27, 20, 20, 19, 16, 18, 18, 23, 49, 22, 21, 21, 20, 29, 19, 19, 21, 26, 23, 20, and 22. Okay, notice that the last number that I typed is on the row that's numbered 24. That lets me know that I entered 24 values and I didn't miss any from the data set. Ideally, then I'm going to take 30 seconds to a minute and I'm going to scan my list and double check that I did not mistype anything or anything like that. Because guys, if you enter the data incorrectly, then everything you do after that's going to be wrong. Okay, so it's important that you get it entered correctly. Okay, so we've got the data entered. Again, your data will already be entered. You're just going to copy and paste the data set. Again, we want to create a graph. So again, logically, we go to the top menu bar to graph. I want to create a histogram. We keep it simple and we're only doing one variable. So I click OK. I have to choose the variable. Now notice here, even though I have 2 columns in the data set, because I had the eye color and now I have ages, Minitab is smart enough to know you can't make a histogram with eye color because it's qualitative. So it doesn't even give you that option. Okay, so I'm going to choose my ages. I'm going to click OK. And again, it creates my histogram. Now, remember, we talked about that the histogram has the bars that are contiguous. They're smacked together. There's no gaps between them. Minitab chose a different scale from what we had. It's okay. But notice, guys, if I hover my mouse over the bars, I've got my mouse on that first bar. It tells me that I have one data value. The value is 1. So I have one data value in the group 12.5 to 17.5. For the second bar, I have 17 students that were between the ages 17.5 and 22.5. Third bar, there are 4 values for 22.5 to 27.5. So you can get information from the graph by hovering your mouse over the bars. Again, it defaults and says histogram of whatever the category name was or the group name was. Again, we like to have details in the title. If you select the graph, you can again go to graph options and change the title. So I might say ages, in years, GHC students, and instead of abbreviating fall 22, I might put that as my subheader or my subtitle. Again, as soon as you hit enter, it changes. Details: who, where, what, when. I can also, again, select it, use that little downward arrow and copy. And I can take it over to a Word document and paste. Okay. Reasonably straightforward. It's not intended to be difficult. So that's kind of where we stopped. So I want to pick up today because the next step in the process of ultimately answering our question is to begin to analyze the data. And when you begin analyzing the data, there are 5 different characteristics that you want to consider. So I want us to talk about what are those 5 characteristics that you want to consider whenever you are analyzing data. Okay, what are the 5 characteristics that we look at when we're analyzing data? And we're going to be talking about all 5 of these, not today, but in more detail over the next few classes. Okay, so we have 5 characteristics of data. The first one is the center. Okay, the center gives us either the middle of the data set or what most people refer to as the average. But again, the word center, I hope applies to you kind of middle or average. There are 3 measures of center that we will focus on in this course. Okay, I like to call them the M&Ms because they all start with M. You have the mean, the median, and the mode. You'll have to wait. My husband. All right, question 2, our second one is variation. Okay, the second one is variation. Variation has to do with how the data values differ among themselves or from sample to sample. Okay, variation is the noun form of the verb vary. Okay, vary means to differ. So the measure or the variation lets us look at how does the data differ among themselves. If you're looking just say at our data set, how do they differ among themselves? Like we can see that we had a low of 16 and a high of 49. So that gives us about a range of about 30 numbers, 30 ages. But we can also compare sample to sample. The 930 class had a low age of, I believe, if I remember right, 18 and a high of 57. So that's almost a 40 point or 40 points, a 40 age spread. So we can compare them either internally or externally. There are three measures of measures of variation that we'll focus on. We use range, standard deviation, and variance. The third characteristic is distribution. And this really has to do with the shape, how the data is kind of put together. Do you have lots of data that are on the low end? Do you have lots of data that are on the high end? Do you have lots of data that are in the middle? Okay, so this is more, we usually relate this to a graph. Okay, we think about the shape, looking at the graph. We look at it both visually, using our eyeballs and kind of our gut instinct. But we also have a way to algebraically prove it by showing the numbers. And we will do it both ways. If you were to Google a statistical distribution, you would probably see lots of options. You know, you might have, I've seen it where there's, 6, 10, 12 different options. We are going to keep it as simple as possible, and we are going to focus on 3. And they're the 3 primary distributions that you'll see. And all the others can kind of be dumped into these 3 categories, if you will. So our 3 options are going to be skewed to the right, symmetric, and skewed to the left. Okay, skewed, bless you. Skewed in terms of statistics is the idea that you're off center. Okay, and you can be skewed either to the right or to the left. Just like we kind of have left wing and right wing. Okay. Number 4 is outliers. Okay, outliers are data values that do not fit with the rest of the data set. Okay, outliers are those data values that just don't seem to fit with the rest of the data set. And sometimes those outliers can actually be true data values. For example, not to offend anybody, but for example, in our data set, we have a low of 16, which is a little unusual for a college student. Okay. And then we have a high of 49, which again is a little unusual for a college student. If you look at research, okay, research tells you that a typical college student is usually between the ages of 18 and 24. Now, there's nothing wrong if you don't fall into that window. But then what that means is, somebody may come across our data set and say, Well, where in the world did you get 49? Did you write it down wrong? And sometimes that's why you end up with outliers, is because maybe when you were recording your data, you wrote it in such a way that you couldn't read it, or you misheard the person when they spoke, and so you wrote it down wrong, and then it winds up in your data set. Again, it's also true that it could be a very, it's an actual real live data value as we have in our data set. Okay, but the outliers are the values that just don't seem to fit. I always imagine in my mind, sounds kind of crazy, but when I'm thinking about outliers, I always think about the cow that's out in the field and it's just standing out there by itself. It's not with the rest of the herd. So it's outlying in the field. You know, it just doesn't seem to fit. And you can have data values, outliers, you can have ones that are really, really low that don't fit, or you can have them really, really high that don't fit. So they can occur kind of at either end of the data set. Again, for outliers, we have a way to identify them both visually, again with our eyeballs and our gut, but then we also have a way to algebraically prove, verify without a doubt that we do have those outliers. We don't have to rely on someone's interpretation of the data. The last characteristic is time. And I hope it makes sense to you that data changes over time. I mean, think about it. If you go back, you know, and look at maybe the average lifespan, or how long the person's going to live, and you go back, say, to, you know, the 1700s, you're going to get a value. If you look at the 1800s, I bet you get a different value. And as you move into the 20th century and the 1900s, I bet you even get another value. Okay, because as we've had medical advances, and that kind of thing, it's going to change over time. Think about the stock market. It can change from hour to hour, day to day, week to week, month to month, whether a stock is going to increase or decrease. Within business, you can think about sales. Depending on what you're selling, the sales could go up or down, depending on the time of the year. And again, they can change from day to day, week to week, month to month. So data does change over time. So that's why it's important that you kind of document when your data was collected, because that can make a difference in the interpretation of the results. Time is the one characteristic that we do not talk about a lot in this course. It's a 15-week course, guys. And we're about 5 weeks in. And so we just don't have, quote, time to do that. But we will talk about the other 4. We're going to actually talk about, initially, distribution, because the distribution is related to the graphs that we have been talking about, that I kind of reviewed with you just a minute ago, the stem and leaf and the histogram. And we ultimately also will talk about what's called a box plot, but we got to have some background information to do that. Okay, so let's talk or focus for a minute on the distribution. Okay, let's talk about the distribution. Again, distribution has to do with how the data is kind of grouped or spread out, how it's kind of clumped together, kind of how it's organized, if you will. And again, this is basically, we look at it really from a graphical from a graphical perspective, we initially do it with our eyeballs, but then we also have a way to verify it. And there are three that we're going to talk about. The first one is skewed to the right. It really doesn't matter what order I do these in. Okay, I tend to start with skewed to the right. With skewed to the right, you're going to have lots of data values on the low end and very few data values on the high end. Okay, so that's kind of a description. With skewed to the right, you have a lot of data values kind of clumped or grouped together on the low end, and you have very few data values on the high end. So it kind of looks, just a rough sketch is going to look something like this. On our horizontal axis, our scale will always run low to high. On the vertical scale, we'll have our frequency. And you could be looking at a histogram. You actually could even be looking at a stem and leaf. Okay, but visually, what it may look like is something that looks like this. Okay, again, you have lots of data values on that low end at the beginning of the graph. So you get this big hump because you have lots of them. And then as it moves to the right, or it's called tapering off, as it tapers off, your frequencies get lower. So you have very few when you get up here to the high end. Notice that the hump is on the left-hand side of the graph because it's on the low end, but that the description is skewed to the right. And quite honestly, I just have to remember that it seems backwards to what you would think. If it's humped on the left, it's skewed to the right. Humped on the left, it's skewed to the right. It's backwards to what your mind would tell you. So visually, when you see something where you have a lot of data values on the low end and not many on the high end, we call that skewed to the right. Algebraically, to verify that it's skewed to the right, we're going to compare the measures of center. Remember I told you had three measures of center, mean, median, and mode? We're going to compare them. And in the relationship for skewed to the right, you would have the mode is the smallest, then the median, and then the mean. So the mode is less than the median, and the median is less than the mean. They line up in that order. The mode is first or lowest, then the median, and then the mean. And if that is a true statement, that verifies that our distribution is skewed to the right. The second one is symmetric. The second one is symmetric. With symmetric, most of the data values are in the center with, hold on, it's my husband again. I'm in class, what do you want? He knows I'm in class, so. Most of the data values are in the center with very few on the low end or very few on the high end. Sometimes you'll see the symmetric is called the bell shape, because if you look at it from a picture, again, your scale runs low to high. You have your frequency. Most of your data values, again, are kind of in that center. And so you have very few at the beginning and very few at the end. So when you look at it, it kind of looks like a bell shape. And guys, when you're analyzing these graphs, you got to remember to look at the big picture. It's not going to be a perfect fit. You're not going to find one that is perfectly skewed to the right or perfectly symmetric. If you do, I would be a little bit leery. Again, thinking about comparison, again, using our eyeballs initially, but when we compare these, we would have that the mode is approximately the median is approximately the mean. All three of those values, your mean, your median, and your mode, are all basically the same value or the same amount. Okay, one more. Y'all ready? Skewed to the left is your third option. Skewed to the left, you're going to have lots of data values. Let it focus. Oh, come on. Focus, focus. We're going to play this. Lots of data values on the high end and very few data values on the low end. So it's kind of the opposite of skewed to the right. Visually, again, your scale runs low to high, frequency on the vertical. Okay, and you're going to have, I always think about it like a plane taking off. It taxis down the runway, and then it takes off, and eventually it has to come back down. So that you have a lot of them on the high end. If we looked, and let's see how fast I can do it. If we looked at the grades for the first exam. Okay, here's the grades for the first exam. It runs from 0% to 100%. Notice how most of them are clumped up here on the high end. So this distribution would be skewed to the right because I had a lot of values on the high end and very few on the low end. Skewed to the left, I'm sorry. Thank you, Donnie. Okay, skewed to the left. Again, it's backwards to what you think because my hump, if you will, is on the right. So it is skewed to the left. Didn't have my brain in gear. If we compared the mean, the median, and the mode for skewed to the left, the mean would be the smallest value, then the median, and then the mode. Okay, so for skewed to the left, the mean is the smallest, the median is second, and the mode is third when you go smallest to largest. Now, at least initially, and on class participation 5, you're going to be asked to determine what type distribution you have solely by your eyeballs. We're not going to run the numbers yet. Okay. So if we go back to our histogram that I rough sketched, and I'll pull it back up in Minitab in a minute. But if we go back to this histogram that I rough sketched, what would you guys say? Is it skewed left, skewed right, or symmetric? It is skewed right. We would say that this distribution is skewed right or skewed to the right. Because if you look at it, we have lots of data values at the beginning and very few as you taper off. You can also get that same idea even if you're looking at the stem and leaf. Whether you look at the stem and leaf horizontally, or if you kind of visualize turning it around. Because if I turn it around and maybe even visualize vertical bars in here, okay, what do you notice? Same thing, because most of your data is on that low end. So even the stem and leaf would be considered skewed right. Now, I want to make an important point here. Donnie got it. I want to make an important point. Guys, regardless of whether I'm looking at the histogram or whether I'm looking at the stem and leaf, if you tell me that the stem and leaf is skewed right, you better tell me that histogram is skewed right. Or vice versa. It's the same data set. It's the same list of numbers. It ain't gonna change the shape or the distribution from graph to graph. It's the same whether you're looking at the histogram, the stem and leaf, or we'll find out whether you're looking at the box plot. Now I can almost bet you between my two classes, somebody on the test will tell me two different things. Okay, that's when Miss Robinson just about losing. I mean, it's the same data set, guys. It doesn't change its shape. And just like the tiger doesn't change its stripes. Okay, it's the same data set. If you tell me the histogram is skewed right, you better tell me that the box plot is skewed right, and you better tell me the stem and leaf is skewed right. Now, before we can really verify with the numbers that my histogram is truly skewed right and my stem and leaf is truly skewed right, we got to talk about what are those numbers that we're going to calculate. Okay, so I want to begin that discussion. I've got about 15 minutes. We'll see how far we can get. I probably won't get far, but we'll see how far we can get. So we won't be too terribly behind. Okay, so we're going to begin this group, or this topic actually gets us into what's called descriptive statistics, which you'll recall is one of the branches of statistics. The two branches were descriptive and inferential. In the descriptive area is where we state just the facts. There are no assumptions made. Okay, so some things that I might could tell you based on the data set that we collected. If you're thinking about stating just facts, I can tell you that on September the 7th, there were 24 GHC students present in the Stat 1401-1230 class. I can tell you that the youngest person present was 16, the oldest person was 49. From, I believe, the stem and leaf, I could tell you that the age that occurred the most is 19. The middle value was 20. See, I've learned some things, and they're facts, but I still haven't answered the question. Okay, so we're getting into the area of descriptive statistics where we're actually going to begin to, quote, run the numbers. We're going to do the calculations. But the nice thing is, guys, Minitab is going to do all of the calculations for you at one time. So we're going to talk about all the different descriptive statistics first, and then I'm going to show you how to calculate them. We're not going to get through all that in the next 13 minutes, but we're going to start. Okay, we're going to begin with our measures of center. Whoops, and I should have put measures of, sorry. Measures of center. And I already mentioned to you that there are three. I refer to them as the M&Ms because they all start with the letter M. The first one is the mean. The mean is what most people think about when they hear the word average. Okay, what would you do if I asked you to average the ages of the students in the class? Okay, we would add up all the ages and then divide it by the number we had, which was 24. Okay, again, most people think of that as the average. Statistically, it's called the mean. Statistically, it's called the mean. The mean is the most important of the three measures of center because we use all the data values in the calculation, and we use the mean in other statistical calculations. Okay, the mean is a value unto itself, but then we also use it in other statistical calculations. So of the three that we talk about, the mean is really probably the best. And I don't necessarily want to say more accurate, because one of the issues that we encounter with the mean is that the mean is affected by outliers, because I am using all of the data values, whether they fit with the data set or not. my mean could be inaccurate or not the best representation. Okay, because if I have a lot of data values, if I had a lot of students, say this class who were in that 15, 16, even 14 years old, those low values are going to pull my average or my mean down. It's going to be deflated. It's going to be lower than it should be. Or if I had a lot of students that were in that upper range, if I had a lot of the students that were, you know, in their 40s, 50s, maybe even in their 30s, okay, because I have a lot of those higher ages would again cause my mean or my average to be inflated. It would cause it to be higher than it should be. So that's one of the problems or challenges we have with a data set. We want to kind of know from the beginning if we have outliers, kind of think about, well, should I use the mean to represent the measure of center, or should I use something else? Again, ideally, we want that mean because it is one of the more important values, because we use all of the data and we use it in other statistical analyses. Because the mean is such an important value, we do have a special symbol that you will sometimes see. They use it a lot in research and even in writing reports. You'll see the symbols. So I want to give you some information about that. Okay. Typically, if you see a Greek letter, you know, some kind of weird looking something or another that maybe you don't know what it is. A Greek letter is used in statistics to represent a population parameter. That's another way that we're able to distinguish between whether we're dealing with a sample or with a population is with the notation. And we use Greek letters as for the population parameter. We use English or Roman letters for our sample statistic. So again, not only do you know, it's important that you know whether you're dealing with the population or the sample. And another way that we do that, kind of an added layer, is we use different letterings. We use Greek letters for the population, and we use English or Roman letters for the sample statistic. Okay, for the mean. And not all of these have, really the only two that have special symbols are going to be the mean and then the standard deviation. But the mean, you have the Greek letter mu, which is the Greek letter for M, which kind of makes sense since mean starts with M. And it looks like a fancy U. Okay, the Greek letter mu represents the population mean. For the sample, we read it X bar. It's the letter X, which remember represents the variable, and you see it with a bar across the top. So it's read X bar, and that's your sample mean. Now, you don't need to know the formula, okay? But again, the idea of the mean is you're going to add up all the values and divide by the number you have. If you see it in equation form, I'm going to show it to you, but you don't need to know it. But if you saw it in equation form, the population mean would be, I'm going to add up all of the values and divide by the total in the population. For the sample, I'm going to add up all the values and divide by the number in the sample. Remember, we talked about big N and little n. Big N is the population because that's the big picture, and little n is the sample. That funky looking letter there, that's actually the Greek letter sigma. And in mathematics, it means to add or total. You'll see that not only in statistics, you'll see that in calculus and in more advanced math. That symbol is the Greek letter sigma, and it means basically to add up all the values, total them up. Again, you don't need to know the formula because Minitab's going to do it for you. Guys, nobody, no researcher in their right mind in today's society is going to do this calculation. Nobody. We have the technology to do it, whether you use your calculator, Minitab, some other statistical software, or you can Google and find free websites that will do it. Maybe even apps on your phone. I've never tried it on my phone, so I don't know. Okay. I'm going to stop there. Let me stop the share and let me stop the recording.